Welcome back to the Complexity Science Online tutorial series. This tutorial series is presented to you by AC4, the Advanced Consortium on Cooperation, Conflict and Complexity at the Earth Institute, Columbia University. So far we have seen how complex systems are different from complicated ones. We saw that they have unique behaviors and special internal dynamics such as emerging self-organization, nonlinear causality, and unintended consequences. This seventh model will focus on another key attribute of complex systems, feedback loops. Feedback loops represent the way in which the parts of the system influence each other. We will learn what a feedback loop is, and explore examples of two types of feedback loops: positive or reinforcing feedback loops, and negative or balancing feedback loops. This model will conclude with an illustration of how feedback loops contribute to the system's dynamics over time. It's easy to think about the single elements that make up a system, for example individual members in a herd of animals. However, when we think about complex systems and how they work, we need to think about the nature of the interaction between the different parts of the system. In complex systems, a reciprocal influence between elements of the system is called a feedback loop, an action that has an effect. The effect, in turn, is fed back and influences the original action. Complex systems usually have more than one feedback loop process connecting their elements and contributing to their dynamics over time, as we saw in Model 3, to their emerging self-organization, as we saw in Model 4, and also to their nonlinear behavior, as we saw in Model 5. This may seem a little confusing, so let's look at an everyday example of a feedback loop. When we save money in the bank, the amount of money we have will grow as the bank pays us interest. How does this work in system terms? We start saving with a certain amount of money in the bank. The bank then pays us interest on that money, increasing the original amount of money we had in the bank. The mutual impact continues and the bank pays us interest on the original amount plus the interest we already paid, increasing the amount of money in our account even further. This is an example of a positive or reinforcing feedback loop, as indicated by the plus sign. Here is another example of a positive or reinforcing feedback loop in action. A stampede can start with just one member of the herd starting to run. As we have seen, feedback loop describes the interaction between two elements of the system, in this case the number of running animals and the level of panic in the group. The positive feedback loop is also called a reinforcing loop, because the parts of the system composing the loop reinforce each other, resulting in a mutual growth or decline. In this case, if the number of the cattle running decreases, the level of panic within the herd will also decrease. A thermostat is an example of a second type of feedback loop that is called negative feedback loop. It is also known as a balancing or inhibiting feedback loop, because an increase in one element triggers a decrease in the other, or vice versa. We start with the temperature of the room. Then the thermostat detects a gap between the desired temperature and the actual temperature. The thermostat then triggers hot or cold air to be added to the room. When the target temperature is reached and a gap no longer exists, the thermostat turns off the furnace or the air conditioner. Let's move from looking at one single feedback loop to a more systemic approach involving multiple interacting feedback loops. Here is a more dynamic and humorous example where both a positive and a negative feedback loop are intertwined. First, on the left side is a positive feedback loop linking the number of chickens with the number of eggs. The dynamic here is that as more chickens lay more eggs, then more eggs hatch, which means that there are even more chickens that will lay even more eggs, increasing the chicken population. However, on the right side of the diagram, a balancing feedback loop is at work. This feedback loop helps balance the chicken population. As more chickens are born, there are more chickens trying to cross the road, but more road crossing attempts mean that more chickens will die. This helps us understand the broader dynamic of why the chicken population doesn't continue to increase without a limit. In complex systems, multiple feedback loops are at work as multiple parts of the system interact. Unlike in the previous example, however, feedback loops in complex systems will typically have more than two components within them, and will be interacting with multiple other feedback loops processes across the system. For a more serious example, let's look at a system map of factors that influence obesity, created by the UK government's Office of Science. In this example, the UK government aimed to understand the systemic influences of increasing obesity rates in order to identify the possible approaches for addressing the problem. By looking at each of the clusters in the map, we can see where different elements interact, forming both reinforcing and balancing feedback loops. For example, one of the major influences of obesity is the level of individual physical activity. As parents increasingly model activity for their children, The children learn more activity patterns in early childhood. This increases the value of being active and the level of recreational activity, increasing the overall physical activity. In turn, this reinforces and increases the parents' modeling activity for their children, thus closing the interaction between all these elements into a positive or reinforcing feedback loop. Positive reinforcing feedback loops will increase or decrease the system's behavior faster and faster, in an escalating or declining trend. This dynamic may be familiar to you from Module 5, where we saw the nonlinear behavior of complex systems. These dynamics are also the reason that in some contexts a reinforcing feedback loop may be referred to as a vicious circle, because it can create a dynamic that is hard to stop. The dynamics created by negative or balancing feedback loops, very much like the achieving of a desired temperature in a room controlled by a thermostat, will eventually send the system towards a state of equilibrium. Recapturing the learning from this model, we can say that feedback loops are what describe the interactions between parts of a complex system. There are positive and negative feedback loops. Any combination and number of them is possible in a complex system. The interactions between the system's elements through feedback loops influences the overall behavior and dynamics of a system over time. These are the online sources that were used to create this module. In the following modules of this series, we will explore more of the unique attributes of complex systems, like attractors, networks, and multi-level hierarchies. These concepts will be easier to grasp now, when one has a basic understanding of feedback loop processes. Thank you for watching.